So instead of keeping the heavy DOM element, I replaced that tray with a virtual tray which is very less in size, improving the rendering performance and everything, and hit this, and we are already in. And what it says is that you have to find the gzip settings. So let us scroll down and find something called gzip. Yeah, we got the gzip setting. To prefetch, we will use some magic comments. So this is the magic comment which I was talking about. So before this import, just add this magic comment, and we can add a chunk name as well. We can rename this chunk name as emoji. So we have LCP of 0.2 seconds, and we have LCP of this, and this. So let us go to performance. Jai Mahakal and welcome to Frontend System Design Yatra Season 2, where we are going to talk about performance. It has total 11 modules, and let me walk you through each. So the first module is code splitting and bundle splitting. Then we will talk about how to compress JavaScript bundles, followed by import on interaction, import on visibility, then prefetch, preload, followed by tree shaking, virtual list, and core web. What are core web vitals? And the three pillars, which is largest contentful paint, LCP, interaction to next paint, INP, and cumulative layout shift. So these are all the 11 modules which we are going to cover. And what are the prerequisites? So a basic front-end development is all it is required. Most of the content, most of the topics are framework agnostic. So even if you are a React developer or an Angular developer, it doesn't matter. Because most of the performance approaches are routed through Webpack. So that is why I have chosen Webpack, so that a Webpack can be configured in both React and Angular, so it becomes really very easy for anyone to ramp up. For this tutorial, I have used React examples, but I am pretty sure that a similar use case or similar package exists for Angular or Vue applications as well. So you don't really have to worry about it. Make sure that you understand the core concept and not the working of things around certain frameworks. So make sure you understand the core concept only. And who should watch this video? So this video is for everyone, whether you are a college student in any of the year, as long as you know front-end development, or you are a entry-level professional or a senior as well, then you can watch this video. If you are senior, then you might already know some of the concepts before, but again, there is no harm watching these videos. You might learn something new out of it. There is always a possibility of learning something new every time from the tutorials or the documentations. Each content, each topic has a hands-on experience already. So this is the repo from the previous season where we discussed networking. So I have created another folder called performance, and inside this performance you have hands-on experience for each 11 modules. So CLS, INP, LCP, code splitting, compression, import on interaction, visibility, prefetch, preload, tree shaking, and virtualization. So every topic has a hands-on experience, there is no doubt. And this whole series is curated using free online articles. And these are the links of all the articles which I have referenced to prepare the content or even to prepare the curriculum. So if you go to patterns.dev over here, you can see that if you land onto the performance, they have really good examples, bundle splitting, compression, everything. So this is the source of my curriculum, and there is one more article as well which you will find during the videos along with. So everything is curated from the free online articles, and this is where you will realize the power of free internet. So I think this is going to be really amazing. The season 1 was really awesome. Thanks for supporting me. By the time I'm recording this video, the season 1 has crossed more than 16k views and more than 1.2k likes already. So make sure that before starting this video, you like this, share this with your friends, and after you finish this particular season, then do comment how did you like this video and any topic you want me to cover in the next season as well. Obviously there is going to be a season 3 as well. I am planning it out, but this was all for the introduction. I think let's get started straight with the curriculum. Let me introduce you to ZQ Cloud. ZQ Cloud is a global communication service provider which provides developer-friendly and powerful SDK and APIs to build many communication features on their app, such as video call, chat, video conferencing, and live stream, or a bunch of UI kits which helps you build faster and ship more with the UI kits. UI kits are build components that you can integrate in your application in shortest possible time instead of building them from the ground up. ZK Cloud has more than 20 UI kits, more than 50 components which are open source, cross-platform, easy communication, and ready to use. ZQ Cloud offers voice call SDK to build app in low code. You can build crystal clear voice conversation with voice call SDK. Here are some of the features like direct call, group call invitation, live video streaming, spatial audio, screen sharing, followed by fun and engaging audio effects, AI noise reduction, intelligent voice processing, recording, call quality monitoring, and multi-device support. You can integrate interactive, real-life audio into every aspect of life, such as social, in-game voice, audio conferencing, and IoT devices. You can register at Zico with 10,000 free minutes. The steps are really very simple. You just have to hit sign up, your name, last name. You can select your country and you can enter your email. Okay, you can get the verification code. You can also verify the stuffs. So you will get a email verification link. So you can check your mail. You can set up a very strong password. Once you land, you'll see a dialog box which will ask for some of your details. So you can provide the details, and maybe you can give this a little detail, your mobile number, and you can hit enter and you can go to the dashboard. As you can see that I have already received 10,000 free minutes, and this is my balance overview, and the overall dashboard is really very cool and really very easy. And you can see list of all your projects, stats, billing, and package. So overall, ZQ Cloud is really a one-stop solution for all video and chatting features for your projects. Let's come back to the video. Alright, so let's get started with the first module, which is code splitting, also known as bundle splitting. It is a technique in which we separate the code into several packages or components that can be loaded on demand or in parallel depending upon the technique you are using. And this means that they are not loaded into the main JS file, or they are not loaded in the network until they are needed. So let me show you what the network logs look like before and after implementing code splitting. Obviously, we are going to implement this app, but let me show you what we are trying to achieve. So over here, you can see that this is the app.tsx file, and there are several other components. For example, nav bar, about, contact, FAQ, login profile, and many more. So this is what a basic homepage of the app is looking like. It is not only loading the app, but it is also loading profile, contact, and other JavaScript files as well. And After implementing code splitting, this is what our network tab looks like. We are only importing what is required, which is app.tsx, and apart from that, navbar is also there, but all the unnecessary routes such as about, contact, FAQ, login, profile, they are not being loaded into the network, hence saving bandwidth of the user, so that necessary amount of data or internet can go in loading what is actually required. This is what code splitting is, that we splitted our code in such a way, in such a manner, that we load only what is required and we discard which is not needed. So this is what code splitting is, and this is very well explained in patterns.dev website. Link is already in the description. I have summarized in 2 lines and explained through the diagram, and this is also what they are explaining, and it is also well explained in JavaScript patterns Vercel app as well. You can check it out, again link is in the description. What we are going to implement is we are going to use this Medium article to implement code splitting in React. We will be using Vite to bundle our application, and we are going to follow this article religiously. So let's get started with hands-on. So we are back onto the GitHub repository from the previous season, where we have covered networking, and now it is time for us to create a new folder. Let's call this as performance. So the GitHub repository stays the same. You can always go back to the previous repo and check the performance folder in the same. So since we are doing code splitting, so we are going to use Vite. So let's copy this command and head over to system design Yatra. We will go into performance and let's paste enter. We will call this project as code splitting. This would be a React project with JavaScript. Cool. Then we cd into code splitting and we perform npm I. And we have all the dependencies ready. What we have to do is, let me zoom this. I hope it is visible now. All we have to do is npm run dev, and it is going to start off our application localhost 5173, and this is what the boilerplate looks like. We head over to src app.jsx, and let me clear this off. Okay, so we have basic, and let's clear all the stylings as well. So we have a blank page now. Let's say what this article is saying, that we create several components. We create the folder src/pages. Inside we create 6 files. Okay, so these are all the 6 files that we have to create, and yeah, I think they are using barrel exports. So barrel exports is something we have already discussed in next year's Yatra, I guess. Yeah, where we export all the components from a single file. So let's go ahead and create a new folder. Let's call this pages, and I'm gonna create profile.tsx. Okay, there was issue. Yeah, and instead of using tsx, since we are using JavaScript, so we will be using JSX. So it should not be much of a issue for us. And we export cons the profile. Similarly, we create about.jsx, and let's just quickly fast forward it. Okay, so we have created 1, 2, 3, 4, 5 pages, and we are going to create one index file to perform barrel exports. So I'll create one index.js file, not JSX, because it is just a barrel file to export all the components. And let me paste this, and this is all we are doing. We are exporting everything. Star means everything from dot/about/contact/FAQs/login and/profile. And let me close these files. I think we don't need them anymore. And what we are going to do is we are going to create a router for which we require React Router DOM. So let us go ahead and install this. CD performance and code splitting, and let's do npm I React Router DOM, and we are going to import link. Okay, so let's do that, and this is going to be created in components. So let's go ahead and do that. So we are going to create a new folder. Let's call this components, and let's create file called navbar.jsx, and let's grab this and paste it. So we are importing link from React Router DOM, and this is a navbar component, which is a navigation bar for home, about, contact and FAQs. This is fine. And let's head over to app.jsx, where we are importing all the 5 components, and we are creating various routes for profile, contact, about, FAQs and login. Okay, this looks awesome. So let me grab everything and paste it to over here. And they have not imported routes, so there were some missing issues. Routes need to be imported. Okay, all the errors are gone. We have a navbar as well, which is not used anywhere yet, but I think they are separating private routes with public routes. This is where navbar would come. So what we have till now is, if I head over to the app and refresh and open the network, open the JS tab, let's refresh, you can see that we have various routes for profile, contacts, about, FAQs and login. So if I do /login, I may only get the login component, which is what we are seeing. If I do FAQs, I get the FAQ route and the FAQ component. But this is not what the network tab is telling us. The network tab tells us that even though if you go to login, I am already loading the login.tsx file, but why do I also load profile, FAQs, contact and about when I am not even using it? This is loading extra 3 KB, right, 3, 3, 6, 9, 12 and so on into my network tab, and it is going to cost some bandwidth to the user, eventually slowing down our application. So this is not what we want. We want to load only what is required, and we don't want to load profile, contact, about and FAQ when the only route I am trying to access is login. So to fix it, firstly what they have done is they have segregated the routes into 2 parts, which is private routes and public routes. Private routes are for the users who are logged in, and they can visit profile, about, contact and FAQ. And if they are not logged in, they are eventually going to see the login. And to mimic or simulate authentication, they are maintaining just one boolean flag, which is authenticated, and depending upon the boolean value, we render our path. Okay, so let's implement this right away. So I'm gonna grab this private route and paste it somewhere here, and I'm gonna grab the public route and paste it somewhere here. So this is a private route containing navbar, and public route containing the login. And if we create is authenticated variable somewhere over here, and I change my app component to something like this. So if you are authenticated, you get the private routes. If you are not, you get the public route. So right now is authenticated is false, so which means that we are going to get the public route, which is the login. And if I still check my application, okay, after even segregating these with private routes and public routes, I'm still getting profile, FAQ, contact and about in my network, meaning that this has not helped us in any way up till yet. So what they have done is, this is this was not code splitting, by the way, okay, don't get confused. This was just segregation of public route and private route. Not sure why they have done, because code splitting is certainly not dependent upon public route and private route. It depends how do you load the components. I'm going to show you now. So finally we are here at the part where we are going to apply the code splitting, and for that we are leveraging lazy and suspense. For those who don't know, lazy and suspense I have already covered in React Yatra series. There might be some timelines or checkpoints, you can check out the video. So lazy load, what it does is it suspends the component, and it makes sure that the component is only imported when it is required by the DOM. That is it. That is as simple as that. So we are going to lazy load our components. So instead of importing instead of doing a direct import, I'm going to perform a suspended or lazy import over here. So let me grab this and paste it over here, and I can comment out this thing, and we are going to import lazy. So let me, okay, it is not giving me suggestions anyways. So import lazy from React. So we are doing a const profile equals to lazy, followed by a callback. Inside callback function, we say we perform our import. Okay, so slash pages slash profile slash pages about slash pages contact and so on. So we, instead of importing from a single barrel export, we are importing directly from the files like this. Once this is done, this was what I was looking for. So lazy and suspense is over here, and I'm gonna save this. Once I lazy load it like this, it is, I think, probably going to give some error key. Yeah, cannot convert object into primitive. So once you import it, they become lazy loaded components, which means that it is a kind of a promise. So we cannot directly render promises as a element. So we somehow need to suspend our component. So what they have done is, over here if you see, they are using suspense on top of component. So over here we have FAQs. I just have to do a suspense and a fallback. That is it. So this is what the fallback is looking like. And if we check the final code, so these are all the suspended private routes. Let me replace this. So we have four routes, and yeah, this was the same thing, right? And then we have suspended login route. Let me replace that. Where is it? Over here. And I think I missed something. Let me fix this. Yep. And if I check my app again, where is the issue? And once we do everything and head over to our application, you can still see that we are getting this error. Why exactly this error happening is that because we missed performing default exports from each of the components. So once we are performing this lazy import from over here, you can see that it is exporting we are not doing it something like this, right? It works with import like over here, but with lazy it exports, it expects a default export. So we have to again let me stage our all changes first so that I can show you the diff as well. And what we have to do is we head over to the pages and we remove export and do export default about, something like this. And let's copy this and do it for every other component. And finally for the profile as well. Awesome. And now if we head over to the app and refresh, you can see the error is gone. And more apparently, you can see that we are only loading login, navbar, app.jsx, but this time all the other components like profile, about, contact and FAQ, they were not loaded. So lazy loading routes is always beneficial, and it helps you save a lot of memory in the network as well. And this is how exactly we perform code splitting or slash bundle splitting. And I hope you understood it all the ways. First we tried the normal way and we saw that all the components were being rendered actually. Then we tried segregating in private and a public route, and again the issue was same. Then we lazy loaded all the components, we changed the named export to default export, and we suspended all our components with some dot dot. You can change it to whatever you want. And once that was done, we saved a lot in the bandwidth. So this was one good performance optimization. And if I change it to true, okay, you can see that I have all the nav bar and only the profile was loaded. Now if I change it to about, my about will be loaded. If I go to home, home is not working. Yeah, I think home is profile only, and no new JSX call was made, it was directly called. And if I call contact, and contact will be loaded. So this is how beneficial code splitting is in terms of performance. And you can always come back and refer to these two wonderful articles and also the notes that I have provided. So this was all in code splitting. Next we are going to talk about variations of splitting, which is import on interaction and import on visibility. Let's begin with module 2, which is again extended version of code splitting. So in the previous video we saw a route based code splitting, right? Where if I take you back, we were having various pages and we lazy loaded those pages based upon their requirement of the current route. If the current route is not requiring that particular page, we are lazy loading it, and hence it was not getting loaded in the network tab, right? This is what we did for the route based splitting. What if your particular page has certain UI components that are not required at the moment? So this is called component level code splitting maybe, and we in technical terms we call it as import on interaction, and it is again a very critical performance optimization at component level. So there is this difference between the previous module and this particular module. In the previous module we did code splitting based on the route. In this we are doing the code splitting at the component level. to understand it better, so imagine you are creating a chat application, and this is a single page which has various components like navigation bar, the whole chat UI, with chat widget where you see the messages, and you have a emoji picker as well. So does it make sense for someone to include this emoji package, emoji component, as part of the main component, or shall we lazy load it and import it only when it is required? Okay, this is what exactly we are planning to do here, right? So if we talk about the layman definitions, so lazy loading non-critical resources when a user interacts with UI requiring it, meaning that you only import all of the content, or you import the emoji JSX file only when your user clicks on this emoji icon, then only you load all the critical assets of the emoji. So this is what it is, and again we are going to leverage React lazy to perform or to achieve import on interaction in a React application. Okay, so I hope you understood it. This is just a variation of a code splitting, and next we are going to talk about import on visibility in the next module. So let us head over to our application, and we can, okay, I forgot yeah, I forgot committing it. Let me do that. So all the changes are staged, and okay, so we are done with this, and let me close this, and we can do cd dot slash, and again we are going to use a Vite application. So let me grab this code, npm create Vite at the latest. The project is going to be import on interaction. And what is this? This is going to be a React JavaScript app. Now we are going to import on visibility, and we perform npm I. Okay, so we are finally done over here. Let me open this in integrated terminal. We can close everything, and we head over to src app.jsx, and let me clear everything. We will definitely need a state, that is for sure. So let me clear all the css files. All right, so let me create a simple component, which is message.jsx, and I have created my message component, and I create another file called emoji.jsx, and we are going to generate the component, and let's import emoji from emoji, import message from message, and I'm rendering the message over here and the emoji over here. Okay, and we do npm run dev. Let me open this up, and in the network you can see that we have emoji and the message. Okay, imagine that this message component is nothing but this whole message UI where you can see messages, and this dialog box of emoji is our emoji.jsx. So this, we have kind of simulated the environment over there, and imagine that we are imagine this emoji component is very heavy. Right now it is just 3.3 kb, but when you start develop actual emoji and everything, the file size will increase, and it will eventually not make sense to include emoji.jsx as a part of the main network call. Instead, we want to fetch it on demand. How can we do this? So if I create a button, and call this as show emoji, okay, and on the click of it, I can do something like, let's call this as show emoji, and I can call this as toggle emoji, and let's keep it as false initially. And when on the click of the button, I get the previous value, and I am just toggling the previous value. Okay, and maybe this should work if I set emoji behind a feature flag or a boolean variable, something like this. I think this should prevent emoji from getting loaded, right? Let's check. We are still getting emoji, and if I click this, I get emoji, but we did prevented emoji from getting rendered, saving cost of the heap memory of the DOM. Okay, because you cannot see the emoji JSX over here. So we saved some heap memory like this, but we did not achieve what was expected. We are still, okay, let me reload the app. Okay, on the fresh reload, emoji.jsx is still being loaded, and I as a user might not use emoji at this moment. Okay, I might not use the emoji. I have sent my message and I have left the app. So this extra 3.3 kb costed my bandwidth, my internet bandwidth, and I had to pay for something which was not required. So how can we fix this? We can fix this by lazy loading it very easily. So we are already exporting defaulted over here, and we import lazy and suspense from React, and I do something like const emoji equals to lazy. We have already done this before. Import dot slash emoji. I can comment this out, and I have to suspend it. Okay, so if we don't suspend it, we will get some error. Okay, so if I do something like this, you get some error key component was suspended to synchronous input, and there was no suspend boundary to handle the fallback. Okay, why this error is happening is because while the emoji component is being loaded, it takes some milliseconds to load. So this flag got immediately true, but this component was still being loaded into the browser. It took some time, and by that time React was not sure or totally blank about it, whether what to show while this component is being imported or fetched from the network and being computed, hydrated and rendered. So for that step, React had nothing to show. This is where suspense comes into the picture, and we do something like suspense, and I'm going to put my emoji over here, and let's call this fallback as maybe a loading string should be fine. Okay, and once I do this, my feature is still the same, but in the network I saved emoji from being loaded into the DOM. So I saved on the heap memory, and I also prevented it from getting loaded in the network tab. So I saved network bandwidth as well. So now if I do show emoji, Now you can see a new request was made, and the date and the file was fetched, then the app was hydrated, and so on. Okay, so this is very critical. So in the previous module, code splitting, we did route based code splitting, and this is at component level. Okay, you can see there is no router over here, no nothing, like it is just one route, and inside that we are now optimizing that route also. So there are two steps of optimization. The first was we optimized the route, now we are optimizing the components as well. And a really good example which we have seen is this emoji wala examples. We are going to see emoji example again in the next, I believe. I am not sure, I'll have to check, but yeah, this emoji example was really on the spot, and it couldn't have been better than that. So this was import on interaction, and before I forget, let me put this on the Git. And let me push that. So this was import on interaction. Next we are going to study about import on visibility. Moving on to module 3, which is import on visibility. Again, this is a variation of the code splitting which we have seen before, and also a variation of import on interaction. The only differences between interaction and visibility is that on interaction you import the component on whenever someone performs any actions like clicking, and on visibility we use intersection observer API to detect whether the component is present in the view or not, and once it is in the view we load that component and we call the APIs and everything. So this is a really good optimization where, although the component is, maybe in the second half of the fold, and you don't want to import it in the first flight, so you may lazy load it and make sure that whenever the component is coming into the view, then only you import that component. A really good example has been given on JavaScript Patterns website. You can also visit patterns.dev. They have did a pretty decent job, but again, some of the examples are obsolete and they are not working, so I am not referencing it for this case. But import on visibility, if you see this video, okay, and so if you let me zoom this, I don't know if you're able to see it. So when the second component was about to come, you see it was already pre-rendered. The image is already there, all the text is already there, and it is coming as it is. Okay, but with lazy load, what is happening is, so once I import it, okay, so let me show you. I don't know if it is visible. So right now, did you notice that switch, that change? See, now it has become all dotted border on the second card, and once it came into the view, they imported that component and it is loading, and so will be the other case also. Okay, did you notice that change? So this is what lazy loading is over here, that whenever the component comes into the view, then we are importing it. Instead of doing it on command with click, we are relying on the visibility. Okay, and a fairly good example again regarding emoji is when the app changes. For example, if we are using Snapchat, on Snapchat people are tend to use stickers more often when compared to other platforms like Instagram. On Instagram you don't open emojis that much, you share reels and other stuff, but with Snapchat you or WhatsApp stickers, right, you interact with WhatsApp emojis or Snapchat stickers very often. So it is a very good use case on to import it on view rather than importing it on the click. Okay, so it depends upon the use cases, right? For if for Instagram, importing it on click makes sense because people are not interacting with emojis as often they should, but with WhatsApp and Snapchat the case is different. So there is always a trade-off between optimization techniques. One may work for your company or for your project, but for another project it may not work. So there are certain trade-offs, certain challenges, and it is a very scenario based optimization, and we are going to understand it. They did a fairly good job in explaining as well. They are using React intersection observer API, and they call this use in view hook. They pass the ref and everything, and once that this particular div is in the view, this value becomes true, and we enable the suspended component. This is really very easy stuff, and again we are going to work with the emoji example. So I'll head over to my terminal and copy the wheat command, paste it, and we create a React app. So this time it would be import on visibility. This would be a React JavaScript project. Let's cd into, or maybe I can close this and open it like this. npm I, meanwhile it is happening, I'll open the src and open app.jsx file, and we can clear everything. This is, I think, not needed. Everything is not needed. We get rid of the css. Again we are going to work upon the emoji example itself. So I am going to create one file, call this as message.jsx, rafce into it. If you are wondering where I am doing this rafce, so it is coming from this extension ES7 React Redux React Native Snippets. So that you can install it, and these are the bunch of apps which I have installed. You can have a look. Anyways, coming back to the topic, so let's get rid of import React. Let's save this, and I create one emoji. Oh, what is the file name? And again rafce. Okay, so we have these guys over here, and we are going to leverage the React intersection observer API package. Sorry, so npm I React intersection observer, and I'm going to import suspense, lazy, and everything from over here, and I'm gonna call this hook like this, and let's import a message from /message, and const emoji equals to, this is lazy loaded, so lazy import dot /emoji. Okay, now let me put the message component over here and add a br tag, and then I create a div, then I suspense my emoji, and fallback could be something like loading, and I give this ref to this particular div, and we are all set. This in view, I'm going to show you what is happening. So let me add a use effect. I think I have to import it. Blog in view, and let's paste it over here, and I have to import use effect. Let's do npm run dev, and let's hit localhost. You can see that earlier it was false and it became true. Okay, the in view value. And now let's try to move this emoji component, and let me show you the network. So these are the JS files. So we have emoji and message. Since emoji is already in the first fold means this is the first fold, and whatever is beneath this screen is second fold. So if I try to add some really good break tags, maybe I am able to shift this in the second fold. Let's check. Okay, pretty close. Okay, now let me show you what I am talking about. So this is the message, and let me add some gibberish message over here. Yeah, okay, no worries. So this is the div, and since this emoji is not in the first fold, that is why the value of in view is false. The moment I slowly scroll into the emoji of this, which is over here, you see the value is true. And this is the place where I want to import emoji. So by default, emoji is being imported, whether it is present in the view or not, but I want to import it whenever it is present in the view. So I will do it something like, I will add a variable is in view, and I'm gonna operate it like this and save it. Now if I refresh, you see emoji was not coming. Now if I scroll back over here, see emoji was imported. I don't know if you paid attention or not. Okay, so I am going to slowly scroll and just keep focus over here and on this network tab. As soon as it came, the call was made and this emoji got visible. So this was import on visibility. Again, I have discussed use case, like it scenario use case. The users changes based on your application. If you are something like WhatsApp or a Snapchat, this makes sense. But if you are like something like Instagram, it doesn't make sense. So it depends upon the type of app or the use case you are working on. And it was again all about lazy loading. So we discussed route based splitting, which is code splitting. Then we had import on interaction and import on visibility. So these are three bundle related optimizations, and I think we did pretty good over here. Next, okay, I think I am offline for some reasons. I'll check that. Next we are going to cover is really good technique, which is compression, gzip, and broadly, which is comparison between Hotstar and Coursera. And this is really good stuff. I think you are going to love it. So yeah, this was all in this module. I'll see you guys in the next one. So let's begin with the fourth module, which is compressing JavaScript. So whenever you create any front-end application, you have a development server which runs the unminified version of your code, where if you inspect the source, you can actually see the exact code that you have written. And there is this production build code. When you run the build commands, it generates a minified version of your JavaScript code, and that is served on the servers. Where compression pitches in is that over the top of that compressed bundle, you apply certain algorithms, maybe gzip or broadly, that compresses down your production build even further by 15 to 20%. So this is what we are going to do in this module, where we are going to see what kind of encoding does Hotstar and Coursera does on their JavaScript bundles, and how can we implement our own gzip compression on a React application, and we will eventually serve this over a Nginx server on Amazon EC2. So let us so this is the brief summary of what we are going to do. So gzip and broadly are the most common ways to compress JavaScript, and they are widely supported by modern browsers. There are chances that broadly might not be supported, so you have to have certain things where your algorithm fall backs to gzip. But yeah, that is there, and be broadly offers better compression than gzip. And if you are using next.js, then gzip compression is done by default and you don't have to explicitly perform it. But if you are doing a React application using a webpack or something, then we have to set your compression algorithm in the webpack config, which we will see in a while. And Oyo saw 15 to 20% reduction, and Wix saw 21 to 25 reduction in file sizes after switching to broadly compression instead of gzip. So this is exactly the power of compression. And let us check what Hotstar and Coursera does behind the scenes. So let me open hotstar.com. Okay, and this is over here. Let me mute it. And let's open the network and let me refresh. And you can see that we have various JS files getting loaded. And if I open any one of the JS file, and if you check the response header, you will see that content encoding is BR means broadly. And in the request headers, you can see that these are the type of encodings that the browser is supporting. So gzip, deflate, br, and zustang. I think zztd is zustang, but I am still not sure. But these are type of compressions that it supports. So Hotstar uses broadly compression. And what about Coursera? So if we go to inspect and hit network and let me refresh, so we got many JS files. And let me open this file, which is the CloudFront. You can see that it also has broadly compression. And if you check the request headers, again, these are all the same parameters which we saw for Hotstar, that this browser is supporting these 4 encodings. So all major tech giants do some type of encoding on their JavaScript bundle to improve the performance. So these were the cases of Hotstar and Coursera. And let me take you to the hands-on experience where we are going to create a React application, and we will perform a gzip encoding and eventually deploy that application using Nginx on Amazon EC2. And we will see once we get the network tab, we will see the uncompressed, the unzipped version and the zipped version, and we will compare how much performance we have improved. So we will create a new folder, and I'll call this as compression. Okay, let me clear this up and we can open this in the terminal. And this is the article which we are going to follow to set up React with Webpack and Babel. And so firstly we will create a npm module. So npm init, and I think we can hit enter with everything. And they are telling us to create a src. So we will create a src folder. We will create index.js and index.html. Fair point. So let us create index.js and index.html. Then we will install React and React DOM. Okay. Then this is the boilerplate of the HTML code. This is simple HTML with a root. So let us copy this and paste it in HTML. And this is the index.js file where we are importing React DOM, and we are rendering a h1 hello world. So let's do that. Then we will set up Webpack. If you don't know what Webpack is, so Webpack is a bundler. So whenever you want to generate a production build and apply compression algorithms, you need a bundler. There are various bundlers like Webpack or Veed. You can, and there are other as well. You can choose whatever you are comfortable with. But for this example, we will use Webpack because it is widely used in the industry. So we install Webpack, Webpack CLI, and Webpack Dev Server. So dev server is to generate your development server. Webpack is the core functionalities, and CLI is to run CLI commands. Then we will create our Webpack config file. So outside SRC, inside compression, we will create a Webpack config, and this is going to create the entry point. So let's paste this. Here we are saying that this is the entry point, which is src in index.js is the entry point, and my output will be going in the dist folder. Okay, my output, the final build of the application will be going in dist folder, and this is the place where we will generate the production build and the gzipped build as well. Then we are going to install HTML Webpack plugin. This plugin is responsible for injecting a script tag into the HTML, and so that the HTML can use the JavaScript and it can use all the code. So this is how we are going to inject the plugin. So plugin, these is the array of plugins, and we are saying ki we will be using HTML Webpack plugin, and my HTML resides in index.html inside src, and so it is going to inject my script tag in this index.html file. Then we are going to set up Babel. Babel is your transpiler. Whatever advanced JavaScript code we write, so that is not understood by browser by default. So in order to make browser understand about the latest code, so Babel converts that new JavaScript code into the old plain JavaScript which browser understands. So we will use Babel core, Babel loader, and we are going to write the rules. So after the output, we can define all the rules. Ki bhai, whenever you encounter a JS file, except for node modules, parse that through a Babel loader so that the browser can understand it. And then there are certain rules like the kind of algorithm which the Babel you want to use. So we are using preset env and preset react. React is to understand all the React code. So we are going to give below the loader options, and this is it. And let us put the build and dev commands in package.json, and we are all set. But if you might run the application, you might run into a reference error key. React is not defined, and even if you have installed dependencies, so make sure you add. Okay, let me copy this. I think this should be better. So you change the Webpack config, the preset React with this. Okay, preset React, and make the runtime automatic. This way you will not see any reference error of the React. So we are all set with the application. Let us start the npm run dev, and we ran into some errors. HTML Webpack plugin is not defined. Okay. Yeah, this is a legit error because we have not imported the Webpack plugin over here. Let us save this, and now let us try to run the application. Okay, now you can see the build is happening and the application is running. You can check this. It is running on localhost 8080, and you can ignore this warning. This is a modal for warning, but our application is running, so we can ignore the warnings. So there is no issue with warnings. So this is a hello world. Let us kill this dev build and let us perform a production build. So we will run npm run build, and this is going to generate the build. Now if you go to the dist folder and check the main.js file. Okay, this is your compressed version. See, this is the compressed version of your app. And over here, you can see that it is a minified versions. All the variables names are changed, and all the extra white spacing and everything is automatically handled, so you don't have to worry about it. So let us try to serve this this file. How should I show you? So open file on remote. No, not over here. There is no way to. Okay, maybe I can just directly open this file. So let's go to projects, YouTube tutorial, Frontend system design, Yatra, performance, compression, dist, and let me open the index.html file. Now if I refresh, okay, if I refresh, my main.js file is somewhere around 140 KB. Okay, so we have our production build with size of 140 KB. This is our production build. So I'll write prod build over here as 140 KB. And by default, since we have not set the mode, it is falling back to production. So that should be fine. No issues there. And yeah, now we have to enable gzipping. So for that, we have to I am referencing this article. You can find the link in the description. All you have to do is install this. The Krakow is not required. You just have to install the compression webpack plugin. Okay, so we will hit npm I compression webpack plugin. We are going to import this plugin inside our webpack file, and inside the plugins array, okay, inside this plugins array, I am just going to tell key by use gzip algorithm as a compression algorithm, and finally it can also coexist with HTML webpack plugin as well. There are no issues. Now if I save this, okay, I save this, and if I hit npm run build, let's wait, and here we go. So you can see that my gzip file was also created. Okay, and if I show you the gzip file, it is only not this, it is 45 KB only. So the production build without gzip was somewhere around 136 KB, but after gzipping it, it fairly came down to 45 KB. So we did a roughly 100 KB of savings using just a gzip algorithm. And if your size of your application increases, the percentage of compression is also going to increase, because there is more amount of code to compress, so you'll achieve larger compression. And if I refresh my production app, okay, I am still getting the JS file, which is 140 KB in size. I'm not getting the gzipped version. So you have to make certain changes in the server in order to serve your gzip version. Okay, so we are going to set up a Nginx server. Okay, this is the website which we are going to reference. We are going to create a Nginx server on Ubuntu machine on Amazon EC2, and on that Nginx server we will see how we can enable gzip compression, and we will deploy this production build over there, and we will see how we can serve gzip files. Okay, this is really good hands-on experience. So first important thing is that I take this file. Okay, let me do one thing. So we have this disk thing over here. Let me grab this thing, copy it, and let's get outside the content. Okay, and I am going to create one uh, GitHub folder which only contains my this demoed gzip files. Okay, so inside YouTube tutorial I am going to create a new folder, and I called it as gzip prod demo. Okay, and I paste all of my code over here. Okay, and let us head over to GitHub. We are going to go to repositories, create new repo. Let's call gzip prod demo. Let's be it a public repository, create repo, and I just wanted this thing. Let's open this in terminal, git init, git remote add origin, git add dot, git commit -m, gzip, git push origin master. Cool. So we have this thing over here. We are going to leverage this to clone this code on the Nginx server. But right now let's follow this article, and we have to create a Ubuntu machine, right? So in this article, this talks about enabling gzip on Nginx, but there is also one link over here which says how do we install Nginx on Ubuntu 20. So this is a really great article, but let's head over to AWS, Amazon, and make sure that you already have access to Amazon EC2 install, put up the credit card and something like that. So let's hit next. Let's sign in into the account, and let's skip this for now, and let's head over to EC2. Okay, go to instances. This was the previous instance I have already created, so we don't need it. So let's terminate it. Then we hit launch instance. Let's call this React gzip, and let's select Ubuntu 24 SSD free tier 64 architecture tier 3 micro, and you can, just for the sake of this tutorial, you can proceed without a key pair, and allow SSH traffic, allow HTTPS traffic. Don't select HTTP, otherwise it would become a HTTP network. Then just hit launch instance, and this instance was created. It is already running. Now we have to connect with this instance, so let's hit connect, and you can although this is not the best way, but you can do connect with your EC2 instance with instance connect. Let's hit connect, and it will take you to a bash terminal in the browser itself. And obviously I am going to delete this instance after this tutorial ends, so please don't try to be smart. All right, let's close this one and bring this tutorial in focus, which talks about how to install Nginx on Ubuntu. So Nginx is kind of a server that allows you to host the websites. Okay, simple as that. So we already have a website pushed to this repo. All we have to do is to deploy this production build on Nginx. So I am going to run sudo apt update. Okay, there is some issue. Sudo apt update, sudo apt install Nginx. Hit yes. And I don't think this is required, but anyway, let's try doing this. Nginx full, Nginx HTTP, HTTPS. So it is already enabled, and we can check the status. It is inactive. So we are going to hit allow. And it still says inactive. Hmm. Let's try with HTTPS. And it still says inactive. I don't think it is required right now. So let's go ahead with next steps. And it says active and running. This is cool. And yeah, I think this is okayish. Let's try to access the public domain. So open the address, and it should say okay, it is saying website cannot be reached. How about HTTP? It just usually takes some time, I believe. Let me refresh and check if all the checks are passed. Yeah, all the checks have passed, and we have this thing over here. And I think I have to start the Nginx. What's the issue? Yeah, I found the issue. So I think I forgot enabling port 80 over there. So you can select this, go to security, and you might not be seeing this thing, port 80, because I have just enabled it. So you can click on the launch wizard and click on this, go to inbound rules. And since I have added this, you can click edit inbound rules, and you can add a HTTP port 80 custom and 0.0.0.0/0 and save the rules. Once you do it and you head over to your application by going to details and open the public IPv4 DNS, you will see the welcome screen of Nginx. And if we go to the network, so it is loading your default welcome screen. That is fine. So we have done the setup of basic Nginx. Now is the time to deploy our application first. So let's do ls. So we are not here, so let's do cd // and do ls. Let's go to cd var ls. You will get www. So cd www ls cd html ls, and this is the place where we have to clone. So let's copy the https and say git clone sudo git clone. Okay, so we have cloned the repo, and if I just now go to this route over our Nginx server, and tada, we got our hello world. So we have deployed the production build over there, and currently it is serving, not serving the gzip files, it is only serving the main js file, the prod build, which was of the size 140 kb. Now we have to enable the gzip protocol. It is really very easy. So this is the article which we are going to follow, and so we have to just sudo nano into this file. So let me do cd once and hit this, and we are already in. And what it says is that you have to find the gzip settings. So let us scroll down and find something called gzip. Yeah, we got the gzip settings which says gzip on vary and blah blah blah, and it says uh, enable additional settings by uncommenting all the commented lines, and that should work. So all we have to do is come over here and enable these configurations, and that's it. And we have to save and close the file. So saving and closing is really very easy. So it is something like control X, and it says yes. So hit Y and hit enter. And I think we have done it. Now if I go to my app and refresh, okay, just do a hard refresh once, and we are still not getting the gzip file. Did we miss any command? Yeah, we forgot to restart our Nginx server. So let us do sudo system restart. And I think the Nginx server has restarted. And tada, we got our 45.5 kb gzipped version of the file, and we have finally enabled it, and you can check the content encoding as gzip. Okay, so this is how we enable gzip compression. You can take a homework on your own to perform a broadly compression over Nginx. You can try it out. It should be really very simple, similar steps as gzip. So this was in this particular module where we saw what is gzip, how we can generate a gzip build via webpack, and how do we deploy it on an Nginx server. It was really very crucial. Not everyone teaches this for free online. Anyways, I am aiming to make this front-end system design Yatra course the best course available for free on YouTube. So with that aim, I am creating this. Yeah, but yeah, this was all in this module. I'll see you guys in the next one. So let's get started with another module, which is Prefetch. It is quite important as a part of front-end system design, and it is frequently used. So what exactly is Prefetch? So Prefetch is a case or an asset which is fetched and cached locally on your browser, which is requested sometime soon but not immediately. What I mean by that is, for example, let's take again that emoji example use case. So there are certain applications where you do not expect the user to open or use emojis frequently. For example, Instagram. On Instagram, people usually tend to share reels, photos. It is not built for chats. The chatting applications are merely Snapchat and WhatsApp, where people tend to use emojis, stickers, and GIFs, and so on. So this is a good use case of Instagram, where the user is not likely to open a emoji tab very often. So it is beneficial to prefetch it using prefetch commands, so that all the asset is loaded whenever the browser is ideal. So let me read it out for you. That fetch and cache resources that may be requested sometime soon, but not immediately on the initial load. A prefetched resource is fetched when the browser is ideal and has calculated that it has got enough bandwidth, after which it caches the prefetched resource. So this is what it looks like. You make a network call and you get the bundle files, and whenever there is some ideal time, you fetch another module. And they have so these are certain articles on patterns.dev and JavaScript patterns. You can read it through. I have taken the assets from here. So I am going to show you how exactly we can prefetch the resources. It is really very interesting. So what we are going to do is we are going to set up a React application using a Webpack. So let me create a folder. Let's call this as prefetch, and from the compression I think it would be wise enough to copy config and JSON files. So let's paste it over here. Let me copy this and paste it here, and I think we can use src as well, and we can close this, open this in the terminal. Okay, let's hit npm I so that it is installed all the packages. And this is everything same as before, all the configurations for React using Webpack. And obviously we don't want any compression is not required, so we can get rid of compression systems. And we have this package, we can ignore this as well. Let's do npm I again. Okay, then we have this src, we have index.html, no changes in the index.html. All we have to do is open index.js. Let me create one a root file, app.js, and over here let's do, okay, we have not created the function, so rafce can remove React. This is my app. Webpack prefetch, and let me create one file emoji. We can rafce into it, can remove this, and let's call this emoji. Now we will create one button. On click of that button we will toggle the emoji component. So this is going to be my button, show emoji, and we are going to create a state, const show emoji toggle emoji equals to use state from React. Let's keep it as false, and we will create one function to handle the click of the button. So handle click, and yeah, so we are going to do something like import on interaction examples. This is a import on interaction article where they are importing the emoji package on whenever the emoji picker is clicked. So we are going to do something like that as well. And over here if I do import dot slash emoji dot then, and I think I can copy this stuff over here. So import emoji, we get the module, we do return module.default, and we get emoji picker, and we set this element. Okay, so create element is what I think. This create element is not required. We can directly set it, and let me create one state emoji element and this toggle functionality. Okay, And when this is true, show the emoji element. Okay, this is what we have created. Let's do npm run dev, and let us open localhost 8080. So this is my hello world example, and yeah, I have not made changes in the app. So import app from /app, do it like this. Okay, let's refresh. So if you open the network tab, okay, and if I click show emoji, okay, we have not attached this handle click to button. So on click, handle click. Now let's refresh this, and if I click this, we get 988 JS, which is our emoji file, and it did not render it because we did not set this to true. Okay, now let's or we can do it, since this is toggle, right? So let's keep it true for now. Let us open the network tab. We have refreshed everything. This is the main.js file. Now if I click this, this is the emoji asset 988.js. This is named by webpack, so we don't have to worry about it. You can see that this package was fetched whenever I clicked it. Now this is a small file, so it did not took enough bandwidth or enough time to render. But if this emoji package is used, then it makes sense to prefetch it. And to prefetch, we will use some magic comments. So this is the magic comment which I was talking about. So in before this import, just add this magic comment, and we can add a chunk name as well. We can rename this chunk name as emoji. It is required or not required, it is up to you. We can keep this as prefetch as well. Now if I go back to my React app and if I refresh, you can see this time 988.js was present before. Okay, earlier what was happening is it was not let me show you. So let me cut this, save it. So if I now refresh, you see 988.js was not coming. Okay, it was not coming. Now whenever I click this 988.js was fetched, and it was this much the size. So this is on interaction on command. The import is happening on command. And if this is a big file, it is going to take significant amount of time for us to show the emoji. What we did was we added a prefetch command. Let us remove this chunk name. I will tell you what this chunk name is doing. So once I add this prefetch command, webpack prefetch true, you can see that this is the exact sizes over here, and this was being fetched as a prefetch. Now if you check the headers, you can see the purpose as prefetch. Because of prefetch, it was fetched whenever the browser was ideal. Now if I do import, this 988.js call is made again, but this time it is imported from the prefetch cache. So it has not made a network call, but instead it made a network call, but instead of hitting the server, I got my data from cache itself. So this is what the prefetch command does. And what about the chunk name? So here it is renamed. It was renamed to 98.js. You can rename your packages with something, anything you want. If you just refresh, you will get emoji.js. So it was renamed to emoji.js. Again, this is purpose as prefetch. Now if I click show emoji, emoji.js will be fetched from the prefetch cache. So this was the prefetch command under the hood. This is how we implement it in React, and I hope you understood it. So this was all in this module. I'll see you in the next one. Let's get started with the sixth module, which is preload. Like prefetch, preload is also a early fetch technique. But the only difference from prefetch is that this preload, in preload we fetch critical resources, and the browser does not has any ideal period time where it fetches. So if you have a quick recap from prefetch, I stated it very clear that whenever the browser is ideal, it is going to fetch your prefetched resources. So any resources that are requested but not immediately used are falling under prefetch. But what preload is that you have a critical resources that that is critical for current navigation, such as fonts, images, that are instantly visible on the landing page. So anything you might use within 3 seconds of the initial load should be preloaded. And a good example could be maybe a WhatsApp or Snapchat, where user are tend to use stickers often as soon as they open the chats. So it is a good use case where to open emojis in such applications. So uh, for let me summarize preload that inform the browser of the critical resources before they are discovered. The preload browser hint can be used to fetch resources that are critical to current navigation, such as fonts, images, or images are instantly visible on the landing page. The image below, no, this is, I think, correct. Let me remove this. I think I added it before, but I think, yeah, this is fine. So over here you can see that this is your network, and along with the main bundle, the preloaded asset gets fetched in parallel in the waterfall. And in prefetch you can see that this is a main bundle, and after spending some ideal time, the prefetched bundle is fetched. Okay, so this is the major difference key. If you see, so here, if it is parallel, meaning that it is fetched as soon as it is found, this is preload. If it is in ideal time, it is prefetch. This is a major difference. So we are going to implement preload, and webpack supports like prefetch. Webpack has this magic comment called webpack preload true. Okay, so this is what we are going to implement over here. So I'll create one folder. I'll call this as preload, and everything from prefetch can be used again. So I am going to copy paste everything inside preload, and I can open this in the integrated terminal and hit npm I. So this is same as prefetch, React Webpack configuration. Okay, now let us hit npm run dev, and let us open the app.js file. So this is prefetch over here. So let us refresh the app. You can see that this was prefetched, and if I click it, I get the prefetch cache. Now if I change this to webpack preload true, okay, save this and come over here, you can see that it was not preloaded. This webpack preload is magic comment is somehow not working. Reason is still unknown to me. I have dedicated 2 days on this issue, but no luck on that. So what eventually we have to do is we have to take support of a plugin called as Preload Webpack plugin. My Webpack configuration is this. You can check it. The version is 5. Dev server is also above 5. So magic comment is expected to work. If somehow anyone knows what the issue is, like why this is not work, magic comment preload is not working, let me know down in the comments. I'll definitely have a look. But coming back, if we want to make this work, if we want to make this work, if you want to fetch preload emoji asset over here, we can use preload webpack plugin. But if you check preload webpack plugin, it is kind of archived and it is no longer maintained. So they have this a dedicated another plugin called as Preload Webpack plugin. This one, which works like a charm. So this is what we are going to utilize. Links are already in the description. So let us copy this and let us kill the terminal for now and hit install. And then we can import Preload Webpack plugin inside our Webpack configuration, and we can call this class over somewhere over here. Okay, let us save this. Now if I hit npm run dev command, and obviously let me change it to Webpack preload. Okay, so let us refresh. Now you can see that this is the main bundle. I don't know if you are able to see it. So this is the main bundle. This is the main bundle. In parallel to it, emoji.js was fetched, and obviously in headers there are no such indications where the asset was preloaded or something. And you can see that this is the actual size. Now if I click this show emoji, no network call was made, although on clicking on handle click I am making the import. And yeah, there is one more thing. So this doesn't means ki preload webpack plugin will preload all magic comments. No, it is not like that. So any JavaScript asset which is fine, which it finds, that would be preloaded. So even if I remove the magic comment preload, and if I refresh, my emoji.js is still preloaded. So you can see that in the waterfall, this is emoji, this is bundle file, both are fetched in parallel. So yeah, but you have to be careful when using preload because it can hurt performance, because you are additionally prefetching preloading something along with the main bundle. So obviously the network is split between two bundles and it can affect performance, so you have to be really cautious. So this was preload under the hood. I hope you understood it. The magic comment is obviously not working, so anyone from Webpack team is watching this, please help us out. And this was, I think, all in this video. You have understood it. I'll see you guys in the next module. So let's start with the 7th module, which is tree shaking. And tree shaking is, I think, really very easy but really very important part of optimization and performance. So what exactly is tree shaking? It is a process of eliminating dead code before adding it to our bundle. It's really as simple as that. So let us take this example. So imagine you have a math.js file where you have two functions, one is sum and one is multiply, and somehow you are only using the multiply function in the entire app, and the sum function is not used anywhere. So whenever you are creating a final build of the application, then only the multiply function is present in the bundle and not the sum. This way we prevent the bundle size from having the dead code which is no longer used. And this is exactly why it is named as tree shaking. because over here, so whenever you shake a tree, so all the dead leaves, they tend to fall out. Similar is the case, like you shake your application and it is kind of like all of the dead code is, it sprinkles out and fall on the ground. So this is what tree shaking is, and these are the two articles which I am referencing for the hands-on experience. You can try it out, and the links are already in the description. But the only way it happens is that we add this optimization use export true in the webpack config. The moment we add this, the tree shaking happens in the app. So I'll show you how it is and what it is. So we can create a new folder and let's call this as tree shaking. And from the compression, I think I can copy package.json and webpack config into my tree shaking folder, and I think I can also copy the src. And over index.js, so this is not a React application, it is going to be a simple HTML vanilla JavaScript type with webpack over it. So we don't really require any compression, so we can get rid of compression. And we also don't require React. I don't know if it is visible somehow. Yeah, this should be visible. So we don't need React presets, so we can remove this. And this is all we have in the webpack. And let in the package dependency, we don't need this React thing, and not even the compression plugin, not even React and React DOM, so we can ignore that. So we have Babel call, preset loader, webpack CLI, and dev server, and these are the start script commands. So we can kill this one, open this in the terminal, and I can hit npm I so that it will install all the dependencies. And over here, let me, so I'll be creating two files, which is sorry, one file which is like math.js. So this is what exactly we are going to reproduce. Okay, one sum function and one multiply function and so on. So let's create a new file. I'll call this as math.js. And or yeah, I think this should be fine. And over here I am going to create function sum. It is going to accept two parameters and return as a plus b. I am also going to create one multiply, and it is going to return a star b. And I am going to export sum and multiply. Okay, and inside this I am going to say import multiply from math and say something like console.log multiply 2 and 3. Okay, so this is it, and let us hit npm run dev, and it has started. So if we hit localhost 8080 and open the console, we saw 6 as the output. But let us also check the main dot, the final bundle which is coming up. So I really don't know if this is readable at all over here. So what I'll do is I will create production builds. Let's kill this server and let me do npm run build. Okay, so in the dist we have this main.js, and this is a compressed version of everything, so you are not seeing the dev build. So maybe we can, it would be easier if I change the mode. So maybe this way it becomes better. Okay, I think I, okay, yeah, this was missing, this was extras. Let's hit the build again. Okay, and now this is the main.js file. Yeah, this way it is way too easy to understand. And let us try to find multiply. So you can see that it says webpack require harmony import, and I found my console, we have this multiply. This is index.js. Okay, this is index.js, this is math.js. Okay, inside math.js I found my multiply function and I found my sum function. Both are getting into the build that we have just created. So if I add this magic command which says optimization use export true into my webpack config somewhere over here, okay, and if I now run npm run build, and this is again the dist main.js file, and if we check over here, so I have my multiply function. Okay, so this was my multiply. Okay, I don't know if you are able to see this. This is my multiply function and this is my sum function. But wait, I just talked about how tree shaking removes the unused code and it is not part of the build, but we are still seeing the definition. But here's a catch. So if you, this is not how we read the builds. So over here, if you see, this is harmony export multiply, this is fine, and this is now unused harmony export sum function. Okay, so unused over here meaning that this sum function is not used anywhere, and this is what this function is doing. So if I change it back to false, okay, if I change it back to false and just see how this unused thing gets removed. Okay, see, this unused was just removed and it became harmony export. The moment I change it back to true and create the build, it becomes unused. So this is what exactly a tree shaking is. Tree shaking is the way where we remove dead code, as simple as that. So let me just push everything over here. Tree shaking, and let's put this on GitHub. So this was tree shaking in a nutshell. Really very easy, and I hope you understood it. That was all. Welcome to the 8th module, which is virtual list. And I am pretty sure that most of you already know virtual list. But if you already know this, you can totally skip this part. But if not, then let's understand what virtual list is. So imagine you have a case where for some reasons you have to render thousands of rows on a single web page, and rendering 1000 or 500 rows is very costly for the browser's rendering performance. So we have already discussed what a rendering step is. Okay, so I hope you have completely followed the previous season. So to reduce the rendering performance, or to reduce the sluggish performance, we use something called as virtual list. The idea of virtual list is really very simple, that you only render what is visible. For example, uh, you have a definite amount of screen size, so this is my screen size, and only certain amount of list is visible at a time. Maybe depending upon the size, like maybe 100 or 50 at a time, depending upon the height of the item as well. So let's say, for example, 50 items are only visible at a moment. So instead of showing 1000 elements on the screen, I am only going to render somewhere around 60, so that 50 is available in the viewport. And whenever I scroll, so there are five items above it, five items below it, so that sums up to 60. So this is what the idea of virtual list is. And by you implementing virtual list, you can achieve a 60 fps near to 60 fps performance by just a small optimization with virtualization. So over here you can see we have like 10,000 list, and once the virtualization was implemented, it was reduced to some defined number of items that are only visible in the current viewport, and as soon as you scroll it, these items get updated. So this is the whole idea of virtualization, and even Hotstar also implements it on their living room platform. So let me show you this once. So this is the living room platform. Obviously, I have reduced the dimensions and I am hiding some URLs. Anyways, so let's if I do anchor scrolling, basically I am using my keyboard's up and down arrow to navigate between multiple movies and so on. And this is a living room platform, meaning that this might be running on your Android TV, iOS TV, or any other web OS device like Samsung and so on. So you have this remote to do up and down, and that is the way this content changes. So I am simulating it with keyboard up and down arrow like this. Now that is not what I wanted you to learn. I wanted you to learn about virtualization being implemented. So this thing over here, okay, so this tray virtual wrapper is your actual tray containing some movies and a title. So we have, and this virtual tray is empty div with the height. Okay, now just see what is going to happen. So I am currently over here. Okay, let me come back to over here. Yeah, now as soon as I scroll down, you can see that the number of virtual tray is increased to 2, and if I do it even further down, it becomes 3. If I do further down, it becomes 4, and so on. So instead of keeping the heavy DOM element, I replace that tray with a virtual tray which is very less in size, improving the rendering performance and everything. And this is a in-house implementation at Hotstar, so you don't really have to worry much about it right now. But you understood the gist of virtualization, where it is important. So because on Hotstar, when you land on the web page, you have an infinite number of trays coming on your screen as you scroll down. So you cannot keep 100 and 200 or 1000 number of screens, given that each has n number of images as well. So it will cause choke of your memory in the browser, and it will be really difficult for you to scroll further. So that is why virtualization was implemented. So here virtualization is really very important in terms of living room applications. So how do we implement this? So this is the article which I am referencing. This is virtual list over here, and we'll be creating one small React application, and we will be using React window to implement it. So let us head towards our application and open this in a terminal. We will grab the vite command, paste it over here. Let's call this virtualization, and this would be a React JavaScript. The app is created. Now I can move into this virtualization, perform npm I, and we also need to install React window. So let us install this. And this is, I think, really very easy to install and use. So we will go to src app.jsx and remove everything from over here. Remove this, and empty this and save this. So this React window is installed. Let us import this thing, and let's just copy this row and use this list. So it says index is style is missing. We can ignore that for now, and let us do npm run dev. Okay, so let us inspect this. So you can see that currently I have 1000 elements being rendered, but I only see 1, 2, 3, 4, 5, 6, 7 items being rendered depending upon the size. So if you see, how should I? So 150 is the overall size, overall height of the list, and item count is 1000, that we are aiming to render 1000 elements. Then we have item size, like each item is having a height of 35 pixels, and this is the width of each item roughly. And given this, given the height, given the item size, it automatically renders how many items can fit inside this particular section. And as soon as I scroll, my number of children in this particular height remains the same, but how should I say this, the items are dynamically updated. Okay, so I hope you really understand it. And this was virtualization in the nutshell. It is a really simple, easy task, nothing fancy. So let's commit our changes. And this is a change from previous file. So we can, yeah, I think let's do this. So this was all about virtualization. Next, we are going to start with core web vitals. All right, so let's begin with another section and the ninth module, which is around core web vitals. It has majorly three parts: LCP, INP, and CLS. So we are going to discuss these matrices in detail. So what exactly is a core web vital? So let me read it out for you first. Web Vitals is an initiative by Google to provide unified guidance for quality signals that are essential to deliver a great user experience on the web. So these are some kind of matrices which the Google has provided as a standard, and any website across the internet can be judged based on these three matrices. So this is, I think, now stable. Earlier it was not stable, and recently INP was introduced. So core web vitals are subset of web vitals that apply to all web pages, should be measured by all site owners, and will be surfaced across all Google tools. So There are various kind of web vitals like time to first byte and various other matrices as well, but out of all other matrices, these three are the core matrices that are very crucial for the performance of your website. And as long as you have these three matrices in good position, in the good green signal over here, then you don't have to really worry about other vitals as well. So uh, as a web developer, it is good to know all the web vitals, but even if you know these three major core web vitals, you should be good enough to make your website performant. So this was a quick intro, and this is the website web.dev/article/vitals, where you can learn in depth about all the core matrices and what exactly they are. So we will be diving into three matrices: LCP, INP, and CLS. LCP is for loading performance. So you have a LCP element of your page, which I will tell you how to identify the LCP element. And if the LCP is loaded within 2.5 seconds, you are in a good position. If it is somewhere in 4 seconds, then it can be improved and brought down to 2 seconds. And if it is more than that, then it is very poor. Okay, then we have INP. So whenever someone interacts with your website, be it any click or something, and the amount of time it takes for the next paint is your interaction to next paint. Okay, this is really very easy. We will do a hands-on experience as well. Then we have this cumulative layout shift. It has been there for a while, really very easy. That so whenever you load websites, so there is no automatic layout shift, like elements are not moving here and there all of a sudden after certain seconds and so on. So this is for CLS. So once you have these three matrices, I think you are in a good position to revamp your website and improve the performance. So let's get started with the first one, which is LCP. So let me read it out, this thing, although it is very easy to understand. So I'll just give you a brief. So all the text, images, or a video element that you see in the first fold of the web page, and there is an algorithm by which the browser decides which of these element is LCP elements, and it calculates the loading time of that element, and based on that it judges the performance of LCP. It is really simple as that. So we are going to you can read it out this later. Okay, it is really very easy to understand, I think difficult. So we are going to deal with LCP, and no, there's no need to create a React application. I think we can understand it way better with simple HTML. So I can create a new folder and call this as LCP, and here I can create a new file called index.html, and we can generate the boilerplate code. And let me add a h1 tag and call this as LCP. Okay, so this is the part, and let us use some images. Okay, we are going to leverage certain images and see how it is going to perform. So now what we are going to do is we are going to head over to jscafe.dev, click on solve problems, and we can do something like responsive images. Open this and go to solution, and you will find these cat images as an example. I hope you have already solved this, but if not, then I think this is a really good time to solve this particular question. So if we open this image, so this is a cat image, and if I save this image on my, so I already have this image cat 500. So let me download this over here, and if we go to downloads, so I have these images over here. This is cat 500, which is of size 255 KB. Then we have cat 1500 and cat 1000. Okay, so these are the basic set of images. So let me do one thing, that I can use cat 1000 over here as my normal image. Okay, so let us do something like img src equals to like this, and I am going to say this is the size of the image. Okay, and we can use this go live extension. So I am seeing this LCP element over here. This is my cat image, and to measure the LCP, we have this really cool extension called as web vitals chrome extension. So visit this and add it to your Chrome. Once this is added, open the settings and enable console logging. And where was the other thing? Let me pin this over here. So are we getting it over here or not? No. So I think use timings is what is missing. Yeah, I have to save it, I guess. Yep. Yeah, okay, now we can see these information, right? So we have LCP of 0.2 seconds, and we have LCP of this and this. So let us go to performance. And so in performance, you can also visit LCP, CLS and INP, already shown by Google, but it is good to have these matrices being shown as logs. Okay, so that we can view how much performance has been increased. So in network throttling, I'll go to slow 4G, and now if I refresh, so it is taking certain time, and this time my LCP was somewhere around 6.5 seconds. Okay, this was very poor. And you can also go to performance and hit this record button. So it is going to do a small profiling, and let us wait for the profile to be finished, and it is going to present you with your LCP. Okay, so the moment you hover on this LCP inside this timings, it is going to tell you ki what is your LCP element, which is this cat image in our case. So how can we improve the LCP? So yeah, let's go back to the image. So we have various kinds of images, and the smallest size for me is this cat 500. Okay, so this is a cat 500 image. So one cat 1000 is for larger screens, and I understand that it is okay to use cat 1000 if you have good bandwidth. But if you use src set like it has been used over here, let me grab this src set and paste it over here. Okay, so the best size of image was cat 500. Okay, so this was the cat 500 image, and I can so this was cat 500, and I want to render it at sorry, I wanted to do it over here. Yeah, this was cat 500, and let's render it at 1000 width, and we can probably get rid of these assets. Okay, now if I go back to my app, okay, and I do a refresh, okay, I think the performance throttling was gone. So let me go back, and this is a slow 4G. Now let me do a refresh, a hard refresh. Now you can see that my LCP got improved just because I rendered smaller version of the image that was required. So this is how we improve the LCP. You can also prefetch the image if you have not checked out preload, prefetch, and preconnect video. Preload, prefetch, preconnect, JS Cafe. So this was the video. You can watch this video, how we can preload, prefetch, and preconnect the videos. Preconnect the assets. So you will understand it. So this was how we measure a LCP. We understood what are core web vitals, what are web vitals, how do we measure these web vitals using this extension, and how we can exactly improve the LCP by using SRC set. Fair enough. So let us push this change. And we are all set. So we have covered LCP. Next we are going to talk about INP. It is really very crucial. So I'll see you guys in the next module. All right. So let's start with the 10th module, which is Interaction to Next Paint, INP. INP was introduced recently under Core Web Vitals, and it is a metrics that like assesses the page's performance when the user interacts with it. So for example, I click a button to open a modal. So I expect that modal to open within 200 milliseconds. Like the next paint should happen within 200 ms. So this is what the INP is. And the only factor hampering the INP could be some heavy task going on the main thread, causing the application to choke and unable to perform the next paint. So if the INP is 200 or less, you are fine. If it is 500 or less, it can be improved. If it is above that, then definitely it is very bad and you have to improve it. So to check that, we are going to do a small hands-on experience over the INP. And again, I have referenced this from Web Vitals itself. This is the article link. It is already attached in the description. You can check it out. So let us create a small React application. I hope that, yeah, I think we can do a React application. So this can be shown really easy. So let us open this in integrated terminal, and let me grab the command, and I call this as INP, React application JavaScript. So we do npm i. Now let's do npm run dev and open the src. Let's open this at localhost. This is read plus react. App.css is not required, so I can remove this. I don't need this. And get rid of index.css. And yeah, so we are over here with the small app, and let us open the inspect, open console, and you can see these web vitals information coming over here. Okay, now let's create one example of INP where I create a button which opens up some section in the bottom, and we kind of also and maybe animate it from certain position to some position. So I can create a button or add a heading called as INP, and let's save this. And there is this button. Let's call this open modal. And on click of this, we do something called const handle click. Okay, and let us pass this over here, and let's just change this user state to show modal toggle modal, and let us keep this as false initially. And inside a handle click, I am going to do toggle modal. Okay, and the previous value followed by not of previous. Okay, and let us create our component of modal. I am modal. Okay, so this is the basic app I have created, and if I click on this modal, you can see automatically the INP value comes out to be 8 milliseconds, which is super fast. We can try to simulate, since I am on a gaming device and it has really cool infra i7 and RTX graphic cards and so on. So obviously the system is bound to be performant. We can replicate low power devices if we go to performance and select CPU throttling as 20x slowdown and select hardware concurrency as 1. Okay, get to console, and if you refresh now, you can see there is some increase. So let us wait for this app to finish loading. So it is still loading some assets. Okay, now if I yeah, so you can see that the INP is not that good. Okay, let us clear this, and now if I open this modal, this time my INP spiked to 64 milliseconds. So this is a good number, but again my number increased, so something bad happened. We can downgrade it even further. So if I have some main thread blocking heavy operation going on before we toggle the modal. So for example, I can say something like for let I equals to 0, I less than 1 2 3 4 5 6 7 I plus plus. Okay, and let's keep this empty. So this was hot reloaded, and if I try to open let's refresh this, and I think we can get rid of network throttling. So 20x slowdown and concurrency 1. And if I try to open my modal, you can see that my INP spiked to 712 because it took some time to perform the next paint of this modal. And since there was this blocking operation going on the main thread, causing this toggle modal function to be invoked lately, and in this caused INP to spike up to 712 milliseconds. And if we check our numbers, it went to very poor category. Okay, so this is what INP majorly is. So INP can happen anywhere. Okay, and there are like whenever user interacts with any of your app, make sure that all of the interactions are having a good INP. So let me open up one good use case. Okay, so this is the article which we are going to reference for certain use cases. So there was this guy, he had a problematic component where on scrolling Okay, so on scrolling, every part of the component was getting re-rendered. So he has used this highlight updates when component re-renders in his React profiler. And so to fix this, what he did was he memoized each component, and after scrolling you can see that only this box was re-rendered and all of the individual items were not. And similar was a use case for opening a menu. Like whenever he was opening the menu, his inp was getting spiked up, and he realized that whenever someone opens the menu, maybe on a slow device, the keyboard is also opening in parallel with the menu, causing the app to be sluggish and laggy. So what he did was he decided to let the keyboard open first and then I can open up my menu. For that, what he did was he moved his logic of rendering the list under a start transition. So start transition, it, like if you check react.dev start transition, so it lets you update the state without blocking the main UI. And so using this, he was able to again improve his inp, and it went to somewhere 168 ms. So this was a huge jump, and I think use improvement actually. And so these are certain use cases where you can improve the inp. And there is also one use case of redbus. I have attached the link in the description, you can check it out. But majorly this was all about inp. And next we are going to talk about cls. Pretty easy, but yeah, let's talk about it in the next module. Let's begin with the 11th module, which is CLS Cumulative Layout Shift. As the name speaks for itself, CLS is a matrix where, whenever a user experiences a sudden shift in the layout while he or she lands on the page. So that is what a CLS is. That is what a bad CLS is. And if there is no layout drag happening once the page is loaded, I think you are having a good CLS number. So it is not any definite unit. It is just a ratio. And like 0.1 means good, 0.25 means improvement, and anything above that is very poor. So a good example of bad CLS is ads. For example, you are visiting a page, for example this page, and all of a sudden this ad comes over here at the top and it shifts all of your content at the bottom, something like that. So this is what a bad CLS is. So you have to be very mindful of placing ads or widgets on your screen so that there is little to no drag on the screen for the users. So we are going to replicate a small CLS example in React. I think it's going to be pretty straightforward. Like we are just gonna do a small set timeout, and we will introduce a new div or something considering it as a ad, and then we will measure what the CLS is. So let's call this as CLS. Package name is this React app, React JavaScript. We can close this, open performance, open an integrated terminal, hit npm I, and this is app.css. You can clear this index.css, clear this app.jsx. So we can clear this, and we can do something like show ads, toggle ads, and use state as false. We can get rid of this, and there is some use effect also. Okay, inside this use effect I am going to put a set timeout of 100 milliseconds, and I'm gonna say toggle ads as true, and let us put some h1 tag, call this as CLS, and a p tag, and let us put some lorem ipsum. So lorem ipsum. Okay, let's paste this. And over here, so over here only I am going to create one div, and inside this div, uh okay, let's do it something like this: show ads. Okay, if this is true, then I'm going to show my ad over here, and the style is something like height is 300 pixels. Okay, and maybe we can show some image. uh we can take example of image from LCP, so we can render this cat. Okay, so we are all set. Let's do npm I sorry, npm run dev, and for now let's forget this ad thing, and let us measure. So yeah, it is, we don't need a slowdown. Okay, so this is our application, and there is literally zero CLS happening. So if I refresh, you can see my CLS is zero, which is good because no shift was happening. And the moment I introduce this guy, this Google ad, and you can see my CLS got changed for some reasons. And maybe if I increase the height to 800 pixels, so you can see that how badly the CLS got changed to 0.11. So it is greater than 0.1 by 0.01, and it needs improvement. So this is how we can break CLS. And to fix it, actually, so what is the height of this image? This is 500. So like I can create one placeholder of 500 in size, and instead of doing it like this, I can do it something like this over here, and show ads. Okay, so I have already created a placeholder height. Okay, so this div is already taking the amount of space that is going to be injected via the ads. And maybe while the ads are not there, I can show some loader, skeleton loaders or shimmer, and as soon as the image comes up, it is going to fill that gap. Okay, so now if I check my LCP CLS, sorry, it is again back to zero, meaning that there is no shift at all. So this was CLS in a nutshell. I hope you understood it, and we should also comment this. This was all about CLS, and really thanks for watching this last module.